we'll practice evaluating algebraic expressions with multiple variables, looking at two methods to find the value for an expression. So let's get started. In the previous lessons, we evaluated algebraic expressions by replacing the variables with the given values. And that method still works here. For this example, wherever there is an x, we replace it with a 7. And wherever there is a y, we replace it with a -2. That results in this long expression that we can simplify using order of operations, or PEMDAS, to -16. So the value of this expression at x equal to 7 and y equal to -2 is -16. However, there is another way to evaluate these expressions. In the examples we looked at in previous lessons, the expressions were mostly simplified down as far as they could go, meaning there were no like terms to be combined or factors to cancel out. Today we'll look at the options when the expressions can be simplified further. Again, one option is simply plugging in the numbers and simplifying it down, like we did here with method 1 and like we did in the previous lessons. Another method, though, is to simplify the expression down first before we actually evaluate. So for this example, the first thing we would do is distribute this -1 to the expression within the parentheses, and that gives us -x plus y minus x plus y plus 2. Then we can combine like terms. We have a -x and a -x, that becomes -2x. Y plus y is 2y, and then the plus 2. So now we've simplified the expression, and now we can evaluate by plugging in the variables. So where there's an x, we'll put a 7. Where there's a y, we'll put a -2. That gives us this numeric expression that simplifies down to -16. Both methods are valid. They lead to the same answer. I prefer method 2. I'm comfortable simplifying down algebraic expressions, and I also know I tend to make mistakes when I rush through the arithmetic steps. So the fewer the arithmetic steps, the better. But again, both methods work. So for today's examples, we're going to evaluate using both methods. First, we'll simplify down the algebraic expression, and then we'll evaluate at the given values. And then use the second method, where we plug in the values first to check our answers. Again, we should get the same value. So the first step here is we're going to distribute this -2. So now we have -2x minus 4y plus 2x minus 3. We'll combine like terms. If we have a -2x and a positive 2x, those cancel out. That leaves us with -4y minus 3. So we have simplified down this expression, and the variable x has gone away. So now we have -4 times y, and y is -1/4, minus 3. -4 times -1/4, that's positive 1, minus 3, and that's -2. Now we'll plug in the variables from the start. So we have -2, x is 1/2, plus 2 times y is -1/4, plus 2, and then x is 1/2, minus 3. So we have -2, and then 1/2, 2 times -1/4, oh, I lost a parentheses here. 2 times -1/4, well, that's going to be -2/4, or -1/2. Plus 2 times 1/2 is 1, minus 3. Well, 1/2 minus 1/2, that's 0. So we have negative 2 times 0 plus 1 minus 3. Anything times 0 is 0, so that term goes away. It's 0. So now we have 1 minus 3, and that's negative 2. Again, regardless of the method we use, we end up with the same value. It's a great way of checking your answer. Okay, to simplify this expression, we'll start with distributive property. Distribute that negative x to both terms in the parentheses. We end up with negative x times y plus 3x plus y minus 2x. Now we'll combine like terms. So we have negative xy. We only have one x times y term. We also only have one y term, so plus y. And now we have 3x minus 2x. Well, that's 1x, so plus x. So now we'll evaluate. We'll plug in these values for x and y. So we have negative 1/2 times negative 3/4 plus y. Y is negative 3/4. Plus x is 1/2. Negative 1/2 times negative 3/4. So 1 times 3 is 3. 2 times 4 is 8. It's a negative times a negative, so that's a positive. And then we have minus 3/4 plus 1/2. We're going to need a common denominator. So this is 3/8 minus 6/8 plus 1/2. 3/8 minus 6/8, that's negative 3/8. And then 1/2 is plus 4/8. And that gives us 1/8. Now let's plug these values in. So we have negative 1/2. Y is negative 3/4 minus 3 plus y, that's negative 3/4 minus 2x. So minus 2 times 1/2. This gives us negative 1/2. Again, we're going to need a common denominator here to add. So we have negative 3/4 minus, so 3 with a denominator of 4, that's going to be 12/4. So we have plus a negative 3/4, so that's minus 3/4. And then 2 times 1/2, that's going to be 1, so minus 1. We'll add what's in the parentheses, so negative 1/2. Negative 3 minus 12. Well, that's negative 15 over 4. Minus 3/4. Minus 1. Now we'll multiply. 15 times 1, or 1 times 15 is 15. 2 times 4 is 8. Negative times the negative is a positive, so we have 15/8 minus 3/4. I'm going to go ahead and find that common denominator. That's 6/8 minus 8/8. 15 minus 6 is 9, so we have 9/8 minus 8/8. And that is 1/8. Again, same answer. Now let's look at one with division. So we have x times 8yz divided by xz. Now again, multiplication, the order and the groupings do not matter. So we can rewrite the numerator as 8 times x times y times z all over x times z. And these factors that are the same in the numerator and the denominator, we can cancel out. So we can cancel out the x, and we can cancel out the z. That leaves us with 8y. And then y is 1, so we have 8 times 1. And the answer is 8. By simplifying down first, we greatly simplified the arithmetic needed to find the value for the expression. But plugging the values in still works. So we have negative 3 times 8 times 1 times 4. All over negative 3 times 4. This is going to give us negative 3. 8 times 1 times 4 is 32. All over negative 12. Negative 3 times 32 is negative 96. All over negative 12. 96 divided by 12 is 8. And negative divided by a negative is a positive. And we get 8. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 2 problems. Again, for these 2 problems, we will evaluate using both methods. First, we will simplify the expression down, and then we'll evaluate at the given values. And then in the second method, we will evaluate first, and then simplify down that expression using order of operations. So the first step would be to distribute this 2. We can combine some like terms. Ultimately, we get 4z minus 2x as a simplified algebraic expression, and we then plug in the values for z and x, and we end up with 24. If we evaluate first, plugging those values for x and z in at the start, and then simplify with order of operations, again, we end up with 24. Using both methods is a great way to check your answer. So in this numerator, y times the quantity x minus 5 minus y, both terms have a factor of y. So I factored out that y. The y's cancel out, leaving us with x minus 5 minus 1, which simplifies down to x minus 6. Once again, we were able to eliminate one variable completely, the variable y. We plug in that x value of negative 2, we end up with negative 8. As is always the case, we can evaluate the expression by first plugging in the values of the variables, and then simplify down using order of operations. And again, you end up with negative 8. Continue practicing evaluating algebraic expressions, and I'll see you in the next video.